Hi, Mr. Andrew here, and today we're going to be finding the polynomial roots of this equation. F of x equals x to the fourth power plus 3x cubed minus 3x squared minus 11x minus 6. And this is a degree 4 polynomial because the highest power is 4. It leads it off there. And what we're going to do is we're going to first find the possible roots. We're going to synthetically divide each of the possibles into it until we hack and whittle down this equation until it's an x squared, or when the equation is degree 2, and we'll solve using some of our techniques we learned with quadratic equations. Okay, so without further ado, let's start working this problem. We have f of x, x to the fourth power plus 3x to the third minus 3x squared minus 11x minus 6. What we need to do is what some teachers call P over Q, or it's just finding the possible rational roots. So here I take the factors of negative 6, or the constant, I take the factors of the constant. I can say that's plus or minus 6, and all factors of 6, so that's plus or minus 3, because 3 can divide into it, plus or minus 2, because 2, both positive and negative, can divide in it, and plus or minus 1. And we take that and we place it over the leading coefficient on the term that's carrying the degree. So the x4, the leading coefficient, we want that. So the coefficient there is just 1, so we have plus or minus 1. So if I would take 6 and divide by plus or minus 1, I just produce a 6. So overall, our possibles are plus or minus 6, plus or minus 3, plus or minus 2, and plus or minus 1. And now the next part is where it can be tedious depending on if you pick the right ones or the wrong ones. So without looking at this, I'm just going to have to choose one. I like the smaller numbers just because those are quicker and easier to work with. So I'm going to take my equation right here. I'm going to take my equation and I'm going to synthetically divide it. So I'm going to say this is going to be 1 because x to the fourth has a coefficient of 1. We have a 3, a negative 3, a negative 11, and a negative 6. Okay? And I'm going to synthetically divide into it a 1. And let's see what we get. So I drop down the 1. 1 times 1 is 1. 3 plus 1 is 4. 1 times 4 is 4. Negative 3 plus 4 is 1. 1 times 1 is 1. That's a negative 10. And negative 10 times 1 is negative 10, which is negative 16. This right here, this remainder right there, this remainder right there, that's bad. Don't want that. So I just synthetically divided all that into it. So what I'm going to have to do now is I'm going to have to recopy down this line here. 1, 3, negative 11, and negative 6. And I'm going to have to synthetically divide another number into it. So let me bump this up. I'm going to try a negative 1. So like 1, but just you're flipping the sign. Okay, so drop down the 1. Negative 1 times 1 is negative 1. 3 plus negative 1 is 2. Negative 1 times 2 is negative 2. Negative 3 plus negative 2 is negative 5. Negative 1 times negative 5 is positive 5. Negative 11 plus positive 5 is negative 6. Negative 1 times 6, negative 6 is positive 6. And this is 0. So now what we actually have is we have this x minus the root. So that's going to be x plus 1. Remember that the sign is flipped going in synthetic division. And then we have this right here. We have x cubed. We have plus 2x squared minus 5x minus 6 with a 0 remainder. So this is our new version of the function. It's actually the same function there. Alright. Now this is something we can solve for. We can find one of the roots. We got 3 more in this one. So guess what we get to do? We get to loop back, and we got to say, well, our possibles are plus or minus 6. Sorry, 1 second. Plus or minus 6, plus or minus 3, and plus or minus 1. So we got to take our new function and divide those into it again. So let's go back to our good old function there. Let's bring in a new sheet of paper, and we're going to take that x cubed. Basically, we're going to take the end of the synthetic division, the 1, the 2, the negative 5, and the negative 6. And now we got to synthetically divide something out because that's only that's an x cubed. That's a degree 3 polynomial. We'll have to take something more out of it. Okay? So if we do that, let's try one of the 2's now. Because we've done our 1's, we can try our 2's. And of course, that doesn't mean there that be repeats. That negative 1 could repeat. But we're just going to try a 2. Okay? You know, you just pick a pattern and go with it. So here, drop the 1 times 2 is 2. 2 plus 2 is 4. 2 times 4 is 8. Negative 5 plus 8 is 3. 2 times 3 is 6. And then, oh, lucky me, that canceled out. So now I know 2 factors. I know negative 1 and 2. So I can say this is x plus 1. Again, flip the sign as you place it in. This is x. That's x equals minus 2. Again, flip the sign. And then we have this x squared plus 4x plus 3. And this is our f of x. Okay? And now what we have to do is break this. So now this is an x squared. You see how that's quadratic now? We can actually solve that in like really 2 different ways. If it factors, it factors. If it doesn't, you have to use the quadratic formula. So here, this one does factor. It factors to x plus 3, x plus 1. And then, of course, we have the x minus 2 come down and the x plus 1 come down. So this is our f of x. Now, if this equals 0, if we zero this out, and if we say this equals 0 because we're finding the roots, so that's something that I haven't brought in because we're finding the roots, we set this all equal to 0. Our roots are just going to be the flipped version of these, or if you set them equal to 0 and solve, you can also find it that way. But we'd have negative 1, a 2, a negative 3, and another negative 1. So these are our roots. Okay, if we see that. Now moving forward from there, we can say, because we had a negative 1 twice, we can say multiplicity. If we say the multiplicity of negative 1, multiplicity of 2. Because there were 2 negative 1's as roots. So really, they'll have you do it 2 ways. You can say it's negative 1, 2, and negative 3 as your roots, and you'll have to say multiplicity of 2. Or if they just don't care, then you just put in the roots. But they want the multiplicity. Just know that we would have gotten 2 negative 1's. I don't write it twice. I just note that there's 2 of them, and that's called multiplicity. Okay. So hopefully this helps everyone out. If you have any more questions about this, don't hesitate to ask. Thank you.